Hello guys, welcome back. First of all, belated happy Diwali wishes to all of you. This is the fourth lecture of the series Electrical for GATE and IES. In this lecture, we will be discussing numericals which are based on sinusoidal sources. These numericals are important from the point of GATE and IES exams. This is all about me. I have done BTech from BIT Misra, MTech and PhD from IIT Kharagpur. I have cleared GATE and Indian Engineering Services exams. So we are going to solve some numericals which are based on sinusoidal sources. Let us first understand phasor diagram concept, which is very important to solve these numericals. We know that a vector has a magnitude and a direction, and in two-dimensional diagram it can be represented like in the diagram shown. A vector r, it is at an angle theta with x-axis. Its x-axis component is having magnitude rx and y-axis component is having magnitude ry. Mathematically, it is given by vector r is equal to rx I cap plus ry j cap, and rx is further equal to r cos theta, and this ry will be equal to r sin theta, and it will be equal to r cos theta plus j cap r sin theta. And it can also be written like mod of r at an angle theta. This is the basic concept. Now we can play around it in mathematics as the situation demands. We will see in numericals. This is the first numerical which we are going to solve today. The circuit shown, equivalent current source has been asked. So voltage source is given as 100 at an angle of 30 degree, and we have an inductance with impedance of 4 plus j cap 3. Let us write the voltage source. It is 100 at an angle of 30 degree. In phasor diagram it is shown. So it will be 100 cos of 30 degree plus j cap 100 sin of 30 degree, which will come out to be 50 root 3 plus j cap 50. Current is given by V by XL. So voltage source is we have simplified, and XL is given as 4 plus j cap 3. So on simplification it will be like this, and its magnitude comes out to be 20. So by looking at the options given, we can just pick the right answer. Now we move on to the next numerical. In this numerical, currents I1, I2, I3 enter a node, and I1 and I2 are given, and we have to find I3. So we see the diagram, phasor diagram. I1 and I2, circuit diagram. I1 and I2 enter a node, and I3 also enters the node. So I1 plus I2 plus I3 will be equal to 0. I3 will be equal to minus of I1 plus I2, and substituting for I1 and I2, we will get 6 sin omega t minus 8 cos omega t. We draw its phasor diagram now. We take sin omega t as the x-axis and cos omega t is as the y-axis. So 6 sin omega t is like this, and 8 cos omega t is here because it is minus 8 cos omega t. So the vector I3, that is equal to 6 sin omega t minus 8 cos omega t will be like this. So mod of I3 will be under root of 8 square plus 6 square, and angle theta, tan theta will be equal to 8 by 6. So we get I3 as 10 at an angle of 53.13 degrees. In fact, tan theta will be equal to minus 8 by 6. So the angle theta will be minus 53.13 degrees. So basically we have changed the frame of reference in this question. We have taken x-axis to be sin omega t and y-axis to be cos omega t. Then we have solved for I3. So we got its magnitude and angle. But now we know that this angle is with respect to sin omega t. So when we write the equation for I3, its magnitude is still 10, but the angle will be, for x-axis, sin of omega t minus 53.13 degree, and for y-axis it will be cos of omega t plus 90 minus 53.13. So it will be 10 cos of omega t plus 36.87 degrees. Now we can see that the y component is on the downward side, so it will be minus 10 cos of omega t plus 36.87 degrees. So this numerical is solved. If you have any doubt, please ask in the comments. It is a good numerical to get the concept of this phasor diagram and different frame. Now we move on to the next numerical. In this numerical, a Thevenin equivalent circuit is given, which is having a frequency of 5 radians per second. It has an open circuit voltage of 3.71 at an angle of minus 15.9 degrees, and it has a impedance of Z0 is equal to 2.38 minus J cap 0.667 omega. At this frequency we have to find the minimal realization of the Thevenin's impedance. So basically we have to find the value, the Thevenin impedance, what it is composed of. So first let us draw the diagram. If the Thevenin's equivalent impedance, it will have a resistance in series with a capacitor or a inductor. If it is having an inductor, then Z will be equal to R plus J omega L, or simply R plus J cap XL. And if it is having a capacitance, then Z will be equal to R plus 1 by J omega C, because XC is 1 by J omega C. So it will be equal to R minus J cap XC, where XC will be 1 by omega C. We can derive XC and XL as shown here. So this is for clearing the concept related to XL and XC. You can go through it. It is given that Z0 is equal to 2.38 minus J cap 0.667. So we know if it is minus J cap, then it will be a capacitor. So Thevenin's impedance is a resistance in series with a capacitor. Now we move on to the next numerical. In this numerical, we have to find the maximum power that can be transferred in the load ZL. So this circuit is given. In this, voltage source is 50 at an angle of 0 degrees. Inductance is J cap 50 and the resistance is 10 ohm. Now we know that from maximum power transfer theorem, then that the power transferred to the load will be maximum when ZL, the output, the load, that is equal to the complex conjugate of the input impedance. Now the input impedance is given as 10 minus J cap 50, 10 plus J cap 50. So the load should be 10 minus J cap 50. Now in this case, current will be equal to voltage by resistance. The voltage is 50 at an angle of 0 degree, that is as good as 50 only. And the equivalent resistance will be 10 plus 10, 10 for the input and 10 for the load resistance. So it will be 20. Now the power, the maximum power will be equal to I square R. I is equal to 50 by 20, that is 5 by 2 whole square, into the output load resistance is 10. So the maximum power will be 62.5. So this numerical is also solved. If you have any doubt related to any numerical, please ask in the doubts in the comments, and I will try to clarify it. If you have any other doubt as well, you can simply ask. Thank you for watching the lecture. If you have any doubts or any suggestions, please comment. If you find the lecture useful, please share it with the relevant audience so that more people can be benefited from it. Thank you.